Hello quantum enthusiasts, and in the last video we completed coding our quantum buttons except for the three Rx, Ry and Rz. And so in this video we will be working with these buttons uh, and we will see why they are different from the other ones. So let's answer the last question first. So why are these buttons different than the ones we worked with in the last video? So the point is these are parameterized gates. And what does that mean? Mean is that it takes a value theta and it uh, does rotation by that particular value of theta and apply. It applies rotation to the state vector by that custom value theta. So in other gates like the Z gate or the Y gate, X gate, S gate, we just had to click the button and it was definite amount of rotation that it used to give. But that's not the case with these gates. They give a rotation in their respective plane, but with the custom value of theta. So that value can be pi, 2 pi, pi by 2, also negative pi by 2, negative 2, so and so on. So for to get that user input, we need to code this little extra functions so that it will give us ease while working with these gates. So exactly speaking, we will need two functions for this, and let's see how that happens. Let me just uncomment this thing. Now note that we will be using another window to take the user input, right? So as you can see here, we do that standard thing. We define the tkinter.tk instance here. You can just think of it here, this get input as our window that will pop up whenever you click any of the Rx, Ry or Rz buttons, right? Then we give it a title, get theta, and this is the geometry, the size of your window that you want. This is the sort of trial and error method again. Then we don't want either this window to be resizable. So it has a fixed size and the user cannot change the size with their cursor, right? Now, for each of the, now we restrict the user for the value of theta. So the value will range from -2 to 2, so positive 2, with both of the ends included. And these are discrete values that can be passed. So we have in a total here 8 buttons. So we have pi by 4, pi by 2, pi, 2 pi, negative pi by 4, negative pi by 2, negative pi, and negative 2 pi. So these are the 8 options that I've given user to choose the value of theta. Now, what you can do is here, instead of using this button setup, you can just maybe use a entry like the display we have in our main window and give maybe ask for a simple direct integer input maybe and use that because so instead of this 1 by 2 1 by 4 1 2 you can just using it with pi you can just take a single input and multiply that number with pi, so it will be user input into pi times rotation. Again, you can that range give a custom range if you like, maybe not, but I have come up with this thing. I have given 8 buttons and I have asked the user to give any of it, and as soon as the user clicks a button, the window is closed, this window, get input window, because the user has given his or her input, right? So let me walk you through this. This is the tick enter button, as I told you. Then we need to define the window, right? So this is the window, get input, that we want our button to be in. Then we define the height and width. Again, this can be a trial and error. The background is buttons, the background color, and I kept it same as our main buttons. This is the font, so the font style and font size. Now this text value is the value that will be displayed on the buttons. So what is that value that you want your buttons to display? So this is what we want our button to display, pi by 4. So the user knows that when I click this button, it will give a rotation of pi by 4. Now after defining this, we need to link our button to a function that will help it to achieve that particular rotation, right? And you can see here that function is change theta. So let me go back and show you that function. So here we go, and this is that little function. So as soon as I just uncommented, the errors will vanish, except for one, I guess. ONP. Let me import NumPy. So NumPy stands for numerical Python, and it's a great thing that you need to know. It will be used everywhere, especially if you are into machine learning. You will be use it for everything, anything, and everything. For your ensemble computation, there are also other libraries, but we won't discuss about it in this video. So I've imported, and that's the error. Import numpy as np. Oh, sorry, as np. Now it's gone away. So instead of writing numpy every time, it's a sort of shorthand for it. NP, numerical Python. We love Python. And here we go. Change theta. What does it do? So it takes the number of window a circuit. Now it was unnecessary of using this circuit because we already had a variable, a global circuit. We added a global variable. But I just wanted to show you that you can also pass a circuit as an argument, right? This window too. You can directly pass them as arguments to your functions. So it's not like your only standard data types like float, integer, string can be passed as your variable. You can pass your custom classes and variable object like also as a argument to a function. So that was the purpose. And this key is a simple string, nothing very special. So remember in the video uh, where we worked on initializing the circuit, we also defined a variable theta is equal to 0. And now it comes into the picture. So let me just scroll up. It should be somewhere here. And there we go. This friend of ours. Theta is equal to 0. Now this variable theta tracks the value of uh, the theta. Like if we apply a rotation, we need to set it back, right? For another gate maybe, because if I apply Rx gate and after it I apply Ry gate, then it should not happen that now the theta value has changed, because that will completely result in uh, it will result in errors, right? Because you don't get the rotation that you want. You will be getting some error over that rotation, maybe theta plus that theta initial value. So that will be a problem. So we need to think about that as well. Let me get back to our change theta. So we declare here global theta. Now this number is nothing but the value passed by user. So if a user selects say pi by 2, then it's 0.5. This number value is just simple point, 0.5 float. And np.pi is pi 3.142, whatever, until it goes. So it represents pi, np.pi. And now we use a simple conditional statement. So we will pass this string key. So what we do is, if key is x, so if the passed key is x, it means that for we have used our x gate. So correspondingly, we will do this circuit dot rx theta. So that is the value we just got here, and where we will apply it on the qubit number 0, because that's the only qubit we have in our circuit. And after we applied that, we will set theta back to 0, right? So we don't run into problems later on, because say if I first use rx gate and I give it a value of pi, and then if I use ry gate, and even if I give a value of pi, it will result in actually a value of 2 pi, because it will add pi plus pi. So that will be problems, and to avoid that, we again set back this value to theta is equal to 0. And similarly, we will work with this thing. So t is equal to y denotes the ry gate. We apply the corresponding function. So we have also have the quantum effect of the gate. And if it's not x or y, it has to be rz, because we only have 3 gates that use this function. So undoubtedly, if none of the two conditions are met, it has to be rz. So we again apply this rz function. So we have our quantum effect of rz gate on the 0th qubit, and then what we do is we destroy the window. And this window is nothing but our window, the user input window, that helps us to take the value of the integer that will multiply with pi here, right? So that's one thing. So you just notice here, you can also pass window as the argument. Now let's get back here. Now you see here, change theta circuit key. Pass all of it. Now remember, here we are working into the the user input window, right? So here we are giving input to these buttons. These are pi by 4, pi by 2, and all buttons that will now and they will now exchange. They will now use this change theta method. But actually, we need to link this with the Rx, Ry, and Rz gate that actually exist in our main window, right? So we need to move a long way ahead, right? And we need to find our gates. Where are they? Here we go. So now command command is equal to, what was the name of that function? User input. So this is the only function, I guess, that we will use, and from here we will directly access the other thing. And as you can see here, this thing also takes two arguments here, the circuit and the key. So when we use this function, we need to pass these arguments again. I think this is unnecessary, the circuit argument, because it's a global variable, but I have passed it for some reason, maybe just to show you. Okay, that's fine. Doesn't won't cause any errors or some problems. Let me get back here. So command is equal to lambda, our magical word, and then we will use user input We'll pass circuit, which is the global variable. Then we will pass a string, which is a simple X. And the same thing should work for all of these fellows here. The only thing we need to do is just change the string y, and here's z. Though if we even if we don't pass it, uh, the particular z value, it would still work if we just pass an empty string, because it would just follow for uh, by default case. But that's fine, we will just pass it. And I think that's it. We have coded the three gates, and we should just run this and see how it works. Let me press RX. So, did I tell you about this text? I think no. I will get back to you with that. So you can see 8 buttons here that we coded above, right? So if I press this, the window is destroyed and my -2 value is stored. But there's a problem here. The RX is not here stored. Let me get back here. I made a mistake. Uh, I did not pass the display gate. So it needs to be a list of functions. Display gate and RX. Right. So the user input is also displayed on the screen. Okay, I'll just copy this now over these two lines. Now what I will do is just RY and RZ, and here it will be Y and Z. Now that should work fine. So the only reason it did not display because we had not linked it with the display gate function. That was a mistake. I'm sorry for that. And now if I work this thing, now it should work fine. If I and yeah, we got the RX here, and and this is the just sort of notifying the user that yeah, you need to pass in this range, because actually you don't have any option. These are the only 8 available options that you have, maybe 5. Yeah, I close it. So we were talking about this change theta, and then we just got off to change theta and the link was broken. So we already seen what this change theta is, what it does, what it or the argument it takes. Let's get back here. We use the dot grid method, our old friend, to insert our button element into the window, and we give the row and column. We specify these numbers so it knows where to place which button. And we similarly do for all the 8 buttons. At places where we require a little adjustment, we use this sticky. Just for adjusting, how your button is being displayed. So if it's a little going a little off, you can just use these tools for that. Now we again create this text object. So it takes the get input is the window that we wanted to display the text in. I just hide and wait, nothing to explain. And this is the background color that I have directly given as this as a string. Now this is the string. It's something very similar we use for our about button. So that's the thing. We just want to notify the user that these are the possible values. This is the range that you can give your value for theta. And what we do, then we just uh, use and this insert our element here, and that's it. So this just insert, we just pack it, and the insert shows it. And using these two commands, we tell our text object how to display it, from which end to which end. And this get input main loop is the most important part. It makes the window keep running, so it's important as well. And that's it. We are into the user input function. So a fairly long video, I know, but it was the most important video, I guess, because here we saw two functions, how they link with each other, how they are then applied to a button. So a lot in this video. Uh, Maybe I will recap it a little in a next video, or maybe we just go to visualize. Let's see what we do. Till then, if you feel a little confused, watch the video again, and I hope to see you in the next one.